Welcome to video notes on structured design and input, process, output approach. We will be using an IPO approach to our problem solving this semester. Here is an example of an input, process, output chart, also known as IPO chart. This picture is an abstract view of how we use a computer, how we use a program, and how we will develop a software solution to the problems this semester. It will help us manage and organize the parts of programs as they grow larger and more complex. The parts of our input, process, output design. 1. The inputs. This is the information that's provided to our program in terms of data and input. The process is a step-by-step algorithm to achieve the required program outcomes based on the inputs given, and the output are the required outcomes or goals from running the program. We'll start by looking at a simple sample programming problem, and then we will map that into a solution using our IPO approach. Here is the problem. Lyft wants to reward their best customers with a one-time discount. The discount is based on the number of rides taken plus the number of new customers they have referred. These values will be added together to arrive at the discount percent. Output message to the customer with their next ride reward discount and the discount amount based on the input number of rides taken and the referrals they made. Back to our IPO chart. This may not seem obvious, but we are going to start by focusing on the outputs. These tell us what our program needs to do or produce to meet the goals of running the program. Looking back at our problem description, in the narrative, we want to identify the goals and/or outcomes as outputs that we need to accomplish. Look for words in the narrative such as report, output, show, display, or produce. These are cue words for what needs to be considered as output from the program. We see that the last sentence tells us that we need to produce a coupon, next ride reward discount, and the discount amount. So that will be our output from the program. Back to our IPO chart, we will identify discount as the output. It's a good idea to decide on the names of your variables right here and now and add them to the chart. It'll help us be consistent when we code the solution. The next thing we want to do is identify the inputs. Reviewing the problem description again, we now want to find all the information and data that will be provided to the program. Look for keywords such as input, ask, get, retrieve. These will help us identify the inputs we will need to get in order for our program to work. In the last sentence, we see that inputs will include the customer's number of rides taken and the referrals they made. Let's add these to our IPO chart. Now we want to identify the processes. Identifying what needs to be done can be accomplished by subtracting the inputs from the outputs and verifying that we have the necessary information to produce the outputs. The narrative says it is based on adding the number of rides and referrals. Since we get these as inputs, we will be able to calculate the discount amount. Words such as calculate, determine, evaluate will all turn into processes in our programs. So look for these when you're looking through the narrative for the processes that need to be done. Now we have our overall big picture of what this program will need to do. We will organize the code in sections. We'll have an input section that retrieves the inputs for the number of rides and referrals. We'll have a process section that will calculate the discount based on those rides and referrals. And then we'll have an output section that will display the coupon with the discount amount from the program. Things to note about our IPO approach to problem solving. This is a design strategy. We're at a high level here, and so this is language neutral. This approach works really well as our programs get larger. It provides a well-organized structure and something to go back to if we get lost or something goes awry in the program. Eventually, we will need to repeat these steps for each separate part of a program, the input part, the process part, and the output part, when the problems are larger and more complicated. But for now, we will organize our single function program into sections labeled input, process, and output. Here is sample code based on our input, process, output design of the Lyft Rider program. We see 3 declared variables for this program: the rides, the referrals, and the discount. Because these are counting numbers, they're described as ints, and they're labeled as input or output. Then we have an instructions section. It's important that we provide the user of the program with an idea of exactly what the program will do. So the instructions tell the user that the program will calculate their Lyft customer appreciation discount. The input section asks the user to enter the number of rides, stores that in variable rides, and then enter the number of referrals made and stores that in the referrals variable. Then the process section calculates the discount by adding the rides and referrals. The output section displays the discount coupon with the discount amount and thanks the user for being a loyal Lyft customer. Let's take a look at this in code blocks. I'll open my projects. Here we see it has the empty main shell. I have already added the code, so I will remove main and add the Lyft discount.cpp, and I'll expand the sources folder and double-click on our Lyft discount program. So when we write our programs, we want to include documentation at the top of the file. We see that's been added to our main template and then saved as Lyft discount.cpp with a description that says this will calculate a Lyft customer discount based on their number of rides plus their referrals. Scrolling down, the main function begins on line 13, and the first thing the program does is to identify those declared variables for the 2 inputs, rides and referrals, and the output discount that we identified in our IPO chart. Then we provide instructions to the user, telling them what the program does, followed by the input section of the program that will ask the user to enter the number of rides. That value will be stored in variable rides, and ask them to enter the number of referrals made, and that value will get stored in the referrals variable. The process section calculates the discount by adding the rides and referrals, and then the output section displays the discount coupon for the discount amount and thanks them for being a loyal Lyft customer. Let's run the program. Going to build and run, and we see the first 2 lines of output are the instructions that tell the user that the program will calculate your Lyft customer appreciation discount redeemable with the next ride you take with us. Let me scroll. The input section asks the user to enter the number of rides taken. We'll say 7. And the number of referrals made, we'll say 3. We'll keep this simple. The process section calculates the discount as 10%, and the output section will show that the discount coupon for 10% with the thank you for being a loyal customer. Remember, we always want to copy and paste sample output, so I'll demonstrate that again. Right mouse click, edit, and select all. That will capture all of the output window. I'm going to right mouse click. That will put it into the paste buffer. And now I'll close this window and I can copy paste the sample output into the bottom of the file. So recap. We're going to be using a structured design approach using an organizational strategy of input section of our code, process section of our code, and output section of our code. This will always give us a starting point to approach the problems with. We identified rides and referrals as input, so request those inputs from the user of the program. The process section calculated the discount by adding the rides and referrals, and the output section produced the coupon with the discount amount and a thank you for being a loyal Lyft customer. Happy C++ coding!